here's the code I'm trying to run. Unfortunately, I am running into this error, and I don't have time to figure it out before submitting, so I am just going to verbally walk through what should be happening, even though it will not happen. So, in this lab, only buttons 0 and 1 are used. Buttons 2 and 3 don't have any tasks associated with it for the interrupt routine, and then switches 3 and 4, 2 and 3 matter, and 0 and 1 do not. So the tasks of, and there's also a software interrupt timer that would be flashing these LEDs. So the actual ZincBook tutorial code that we ran before editing for this lab simply counted on the LEDs incremented by 1 with probably about half-second delay, and it was 3 timer interrupts for each LED increment, and that's what the buttons will control later, the amount of interrupts per LED increment that would update, which would increase the time or decrease the time of in between the updates for the LED, so it would be counting slower or faster. But before that, switch 3 must be on to enable the button interrupts. So anytime switch 3 is off, the buttons don't do anything to the hardware, to the LEDs, to the code in general. Nothing occurs because the button interrupt is disabled. So if this would be on, again, buttons 2 and 3 do nothing. Button 0 would increase the amount of times the timer interrupt would occur before incrementing the LEDs. So if I were to tap this a couple times, it would go up from 3 to 5 interrupts before the LED would count, increasing the amount of time in between updates to the LED. So it would be 1, 2, 3, and then you'd hit that a couple times and it would go slower to 4, 5, 6. So it would be like, it would just slow the count, or reversely hitting button 1 would make the count faster and decrease the time in between. And the ranges on that, using button 1, you can get to as low as 1 interrupt per LED change, and going up with button 0, you could get all the way down to, or all the way up to 7 interrupts in between LED updates. So the button interrupts are controlling how many timer interrupts are needed per LED update. And in the code, it would be controlling this line right here. Button, or this variable. Button 0 would increase timer interrupts, and button 1 would decrease timer interrupts by 1 each time. So this line only gets called when the timer count here reaches the amount of interrupts. This outer if statement is checking is hit every time that the timer control or the timer interrupt occurs. And as long as the count is not equal to interrupts, the count increases, so that the next time it comes through, if it does, the count is 1 higher, so it would go through 1, 2, 3, and then it would hit for the first time, and it would do that 3 cycles every time before it would increase this LED data variable. Now, after you change the timer interrupts with the button interrupts, this number would change, and you'd have to go through the cycle anywhere from 1 to 7 times, which are the upper and lower limits of the interrupts based on the lab manual. Some of the assumptions I made in this were that button 0 took precedence over button 1, so if that both were pressed, the LED count would increase. And in switch 2, I will talk about the final task that it had. Switch 2, anytime switch 2 went high, a reset routine would be called, which would flash all 4 LEDs together on and off, about a second on, a second off, until all buttons and switches are turned off. So even if I had this switch, if I had both switches on, the reset would still occur because I have the switch 2, the reset is at a higher priority. And even if I were to turn switch 2 off, it would still be flashing on and off in 1 second increments until switch 3 was off and all inputs, meaning the buttons and the switches, are low. So unfortunately, I waited too long to try to fix that problem to actually display it, so I don't know if this video will help much, but I would at least like to demonstrate that I know what is happening and should be happening. Yeah, thank you.